Hey folks, this is Jay from Chandler, Arizona. Have I convinced you on the future of quantum computer yet? If not, this is a video for you. Let's talk about more benefits and some details on why I keep on making videos on quantum computers. The reason I believe is a quantum computer is gonna be real is because high performance scalable cloud computers of classical nature have hit its limit, and there is going to be a point where we will need a quote unquote a quantum leap in computers. And I feel quantum computers or some kind of a different kind of a computer is the way to go. Today, if you see, a lot of the algorithms used in high performance computing can be actually done by classical computers with a lot of power requirements and probably pretty slow. So, for example, analyzing or evaluating the results of clinical trials, analyzing financial trends depending on the investments and other broader global markets, predicting weather conditions. Can high performance classical computers do these jobs? They can. It may take more time and it may be a moot point by the time it figures things out, but it can do that. A quantum computer can do the same computations very quickly and with much lower requirements of power. But this is not the cool thing about quantum computers. Quantum computers across industries have now come to a point where it is solving problems which are out of reach of high performance cloud computers. In the mobility sector, for example, we are seeing, we are seeing quantum computers being adopted to figure out things which are being resolved by high performance cloud computing, but they are being resolved very, very slowly. So there are leaders who are saying, oh, we have time, we don't need this fast, let's not break what we have. Perfectly good approach, but it might be very, very short-sighted. Across industries, and I'm not saying one industry, across industries, quantum computers are gaining traction where the capital markets are doing what it can do best by looking at technologies which can give more efficiency, speed, and accuracy over its predecessor, which is high performance computers. So I would like to talk about three things. One is optimization, second is simulation, and third is hybrid machine learning. Number one is optimization. As I have talked in other videos as well, optimization algorithms are basically one of the sweet spots of quantum computers. Optimizing algorithms basically consider multiple parameters for a particular problems, look at various combinations, and it determines a best possible path to a final outcome which is needed by the solution. One big example nowadays people are looking is inventing new materials which could reduce waste, which could help understand if it is safe in its final state. Another example is real-time figuring out human patterns of car driving in a real scenario, and then helping autonomous driving cars with those patterns to stay safe. Second key example here is simulation. Simulation is used in healthcare companies, in biopharmas to figure out internal energy structures and its permutations or combinations with different molecules. It is used to create new heat resistant materials. You know, how would we colonize Mars? We would need new heat resistant materials to travel there back and forth. To optimize battery development in such a way that it can go for longer distances than what it could do just now. These are just some examples of simulations which a quantum computer can do much faster, so that you don't have to invest a lot in a particular hypothesis for certain materials or molecules to figure out if your hypothesis is right or wrong. Number three is hybrid machine learning. Machine learning is a big area. Generative AI has made AI accessible to the masses, and it has become a real thing. But machine learning, with as people are starting to know, with generative AI to train this model requires petabytes of data and requires millions of dollars. A quantum computer can learn in much lesser time than what a high performance computer can do, and it can learn with much less training data. So you could basically envision a time where high performance computers and quantum computers can work together to figure out valuable use cases, which leads less time to train and less data to train, with all the concerns with data privacy and things like that coming through. One other thing around machine learning I would like to tell is, today, if you look at any of these generative AI tools like ChatGPT or Anthropic's Claude AI, they are not able to tell you why did this particular generative AI tool gave you this answer. They are not able to decipher the permutations it went through before it created that content for you. The reason why it is not able to tell you, it's because it is an empirical problem. And guess what? Quantum computers can solve empirical problems much, much faster. So that is why I feel quantum computers with AI can create a hybrid machine learning area where your key content creation can happen on a high performance computer, but training, deciphering answers could happen on a quantum computer. Thank you very much. If you like this video, please like, share, and subscribe. And if you have any questions, please post it on the video. Thank you.